Alright, today we're doing literal equations. It says solve 4m minus 3n equals 8 4m. What this means is solve for m, we're going to get m by itself. It tells you which variable we want by itself. So first thing I do is I get everything away from it. So I'm going to add 3n to both sides. We have 4m equals 8 plus 3n. I need to get rid of the 4 because it's timesing by 4 and I gotta get m by itself. So I divide this side by 4, means I divide everything over there by 4. There is my answer. 8 plus 3n equals 4, or over 4. Alright, we have 15 equals 3n plus 6p. We are solving for n. Like I said, we're trying to get a variable by itself. What we're going to do later on is they're going to give us formulas, and you'll have to solve for a certain variable inside the formula. So I'm going to get m by itself, so I do the opposite to everything else. I subtracted 6p to both sides. Then I'm going to divide both sides by 3, and there's my answer. So we have 3x minus, 2y, equals xz plus 5. We're going to solve for x, so what I got to do is I got to get all x variables on the same side. So I'm going to move xz over. So I got 3x minus xz minus 2y is equal to 5. Then I'm going to add 2y to both sides, get it away from x. So here we have 3x minus xz is equal to 5 plus 2y. Now, I want to get x by itself, but we have 3x and we have xz. Right, they're not like terms, so I can't subtract them or add them. But what I can do is I can undistribute x. What I can do is I can factor out x, because x is a factor in both of them. So what I do is I put x out here, and inside parentheses I put what's left. We have 3x, I took x out, what's left? 3. I have that minus sign, I took x out of xz, what's left? Z. Okay, so it looks just like this. The reason I said undistribute is because doesn't this look like a distribution problem? Okay, I distribute, we get 3x minus xz. So we just did it backwards. Alright? So over here we have 5 plus 2y. So we have x times this. So what we do is we divide by 3 minus z. And there's my answer. 5 plus 2y divided by 3 minus z. That's what x equals. Alright? Any questions? Alright, write this down. This is what we've been leading to. They start giving us formulas, and we have to solve for one of the variables inside the formula. Alright, so they give us the formula for circumference of a circle. It's 2 pi r. 2 times pi times the radius. C being the circumference of a circle. We're supposed to solve for r. Alright, what they would do is if they knew the circumference of a circle but they didn't know the radius, alright, they could say find the radius. So we have to find the radius. So I'm going to get r by itself. So I divide both of these by 2 pi. And now I have r by itself, so that's my answer. So if I need to know the radius of a circle knowing the circumference, I take the circumference divided by 2 pi, and I would find the radius. Alright, write this down. I apologize, I misspelled dimensional. It should be NAL. The 10K run, okay, is 10 kilometers long. If 1 meter is equal to 1.094 yards, we're supposed to use dimensional analysis to find the length of the race in miles, with 1 mile being 1760 yards. So this is what dimensional analysis is, right? It's just writing everything like fractions. So you write the first distance 10K over 1. You always write your first distance over 1, unless you're doing rate like kilometers per hour. Then hours will be on bottom. But just doing this, it's 10 kilometers on top over 1. What we do is we times by our conversion rate. Our conversion rate right here, right, we need to go from kilometers to meters. All right, so I'm going to put kilometers on bottom. You always put them on the opposite sides. If kilometers is on top, you put it on bottom. And then put the unit you want to go to on top, which is meters. How many meters are in a kilometer? You guys in science should know. 1,000. It is 1,000. Okay. Then what we do, we times by another conversion rate. We know that 1 meter is this many yards. So meter needs to go on bottom. Yards goes on top. 1 meter is 1.094 yards. Then you look to see, have I gotten to where I need to go? I'm changing kilometers to miles. Okay, I have not gotten to miles yet. So the next thing I do is I convert yards to miles. So yards goes on bottom to cancel out with the one on top. And then we've got 1 mile on top here. There are 1760 yards in a mile. What I do is I go through and cancel out everything that I can. Kilometers cancels out with kilometers. Meters cancels out with meters. Yards cancel out with yards. What's the only unit I have left? Mile, right? Is that what I was going to? Yes. So now I can carry out my operation. What I do is I do everything on top. I multiply everything on top and then divide by everything on bottom. So I take 10 times 1,000 times 1.094, which I will use a calculator for. 10 times 1,000 is 10,000. So 10,000 times 1.094, we'll move the decimal 4 times and you get 10,940 over 1760, because 1 times 1 times 1 times 1760 is 1760. So we divide by that. Now if there was something else, like if this was 10, I would divide by 10 and then divide by 1760, but it's just 1, so we don't do anything. So 10,940 divided by 1760 gives me this, 6.2 miles. And there's my answer. So this is dimensional analysis, where we compare all the units, the conversion rates, we carry what's left, and there's our answer. All right, write this down. A car traveled 100 feet in 2.8 seconds. We're going to find how fast the car is traveling in miles per hour. So we're going to use dimensional analysis exactly like we did before, except we're using rates and not just units. Okay, so first thing I do is I write the rate I have, which is 100 feet in 2.8 seconds. I'm going to times it by a conversion rate. I'm going to get feet to miles. So what I do is I put feet on bottom and put miles on top. Does anyone know how many feet are in a mile?
Like 5,000 something.
5,280. Okay, and then, so I got rid of feet, I'm at miles. Okay, I have miles per second. Is that what I'm going to? What's it asking for? Miles per hour. So what I got to do is I got to change my seconds into hours. So if seconds are on bottom, where do I need to put them? On top. Okay, I don't know how many seconds are an hour, but I do know how many seconds are in a minute, which is 60. And I know how many minutes are in a hour, 60. Okay, if you didn't know, there are 3,600 seconds in an hour, but I wanted you to find that out this way. Okay, seconds cancel out, minutes cancel out. What are the only units I have left? Miles over hours. Is that what I want? Miles per hour? Yes, so now I can solve it. I take 100 times 60 times 60, so 100 times 3,600, okay, is 360,000 over. What we do is we divide that by 2.8, and then divide that by 5,280. So 360,000 divided by 2.8 gives me 128,571.43. Divide that by 5,280. That gives you this, 24.4 miles per hour. And there's my answer. Now you could have taken 2.8 times 5,280 and gotten 14,784 and then divide by that, but it's easier for me to just divide by each thing on bottom. All right, any questions? Easy enough. All right, here's your homework.